Hello all, welcome to standardsolver.com. So today we are attempting to solve this problem. It's a bottle frame with a hinge or a pin connection in it. So I don't know whether we can call it bottle frame, but yeah, a frame. So yeah, let's see how we can try to solve it using standard solver. So this being a 2D frame analysis problem, let's go to the module. So you can go to this site, standardsolver.com too. When you go there, you will be in this screen. Then you can go to this module. So let's remove the default data we have. Okay. So let's create the structure or the frame first. So let's start from the left hand side. So no point A is n1, which is at 0 0. Then point B is 5 meter up above n1, so 5 up. Then node n3, which will be point C, which is 3 meter in the x direction and 5 meter up. So 3, 5. Then node n4 represent point D, where we need to put a point load. So wherever you have loads, or wherever distributed loads ends, you need to put a node there so you can end things there. So in this case, point D is 7.5 meter from point A, and E is 7 meter, C is 5 meter, so D is midway between C and D, so 6 up. So let's enter that, 7.5, 6 up. Then node 4, which represent E, is 12 meter and 7 up. Then node 6 is 12 meter. So we have all the nodes for the geometry. Then let's enter the elements. So element 1 between n1 and n2. Let's keep all the default parameters. We will come back to it. And in element 2 is between n2 and n3. Then n3 to n4. 4 to n5. 5 to n6. So we got all that. Okay, so we have the geometry in place. Let's add the restraints. So the point A is pinned. That means it is free to rotate, but it cannot move laterally or vertically. So let's restrain it in the x and y direction. Same with point F also. So let's do that. True. So okay, now we have this pin at node 3. That means these two elements are free to rotate with respect to each other. How we achieve that is we go to the elements, and this is element 3, which is between n3 and n4, and we release its start point. You can see a dot. That means it is free to rotate. Even though the dot is little off from the node, actually that is just for the visibility. Actually, this element will rotate with respect to this node, so it is released with that joint. Okay, so that's done. See, like, it's just a graphical notation. Let's go back. So now let's apply the point loads which are entered from the node window. So there is a 8 kilonewton in the x direction, then minus 10 kilometer acting downwards, so minus 10. Oh, it's just not here actually, it's a node into, so 8 kilonewton plus 10, then minus 25 here, then minus 30, then minus 15, then there is a lateral load of 10 kilonewton. So we got all our point loads. Then there is this distributor load here, which let's go to that. So that is between node N2 and N3. So that 12 kilonewton per meter is acting downwards, so we need to consider that. So minus 12 and minus 12 at the start and at the end, but it's acting in the y direction. If you zoom in, you can see, yeah, minus 12. So the sections, everything, we just leave it same. Let's run the analysis. See, you got the results. You see the the deformed shape is kind of weird. That is because the section, the default section used here are quite weak to carry these loads. So what we can do is define another section and use it. So let's use this user section which is there by default and see what. So let's change those to user sections. Okay, now run the analysis. You can see there is, this structure didn't deform much. Maybe just to see the deformation, we enter a deflection scale, so there will be some deflection to see. Now you can see the deformed shape. So yeah, I have the results which I already knew, just to check whether our analysis match with the results. So the bending moment results, we can see they are quite matching. Then 270 here, then the shear force 20.6, 52, also the axial load diagram. So everything is in compression. You can see 53.67. Yeah, we don't have the deformed shape, but yeah. And these are the end reactions. So yeah, you can download this report. I will download it and attach with this video, so you can download it from the video, then upload it here, then you'll able to see. So yeah, so give it a go, guys, girls. It's quite easy to use. This is fairly complicated problem, but we managed to do it fairly fast. So hope you enjoy using standard solver. Thank you. And if you have any comments, just leave it down below. I will check them and reply to your questions or any suggestions. Thank you.